Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So let's have this problem on moving loads. A truck-trailer combination crossing a 15-meter simply supported span has axle loads of 20 kilonewtons, 75 kilonewtons, and 120 kilonewtons separated by distances of 4.27 meters and 9.15 meters respectively. So compute number one, the absolute maximum bending moment, and second condition, the absolute or second requirement, the absolute maximum shear force in the span. All calculations must be magnified considering an impact factor given by 15 over L plus 38 and must not exceed zero point 0.3. So here is the first situation. Let's assume first that all loads will lie on the span, and by principle, the maximum moment or the absolute maximum moment occurs under the heaviest load when that load and the resultant of the loads are positioned equidistant from the center line, and the distance between them is E, so the distance from the center line is E over 2. So let's have that possibility. So if all loads are on the span, then R is equal to 120 plus 75 plus 20. The resultant would be 215 kilonewtons as shown, and the distance of the 120 kilonewton load, the heaviest load from the center line, is E over 2, and the resultant of the load is E over 2. So to solve for E, we apply Varignon's theorem, 215. This is our reference. So 215 times E equals 75 times 9.15 plus 20 times 9.15 plus 4.27 is 13.42 meters. So 215 times E equals 75 times 9.15 plus 20 times 13.42 meters. So solving for E is 4.440 meters. So let's now check if really all these loads lie on the span. So 9.15, the distance of the center line to the 75 kilonewton load is 9.15 minus E over 2 minus 2.22, that is E over 2, so that's 6.93. So therefore, the center line, the distance of the 75 kilonewton load from the center line is 6.93 meters, not shown in the calculation, but I just mentioned it. So 6.93 plus 4.27 is equal to 11.2, and 11.2 meters is greater than 7.5. So that means this is incorrect. The 20 kilonewton load lies outside the span. It is off span. So this calculation that will be cancelled or ignored because this is wrong. Thus, only the 120 kilonewton load and the 75 kilonewton load rely on the span. So let's analyze it again. So this is now the situation where the 20 kilonewton load lies outside the span. Therefore, the resultant would just be 120 and 75. So let's place the resultant and the distance from the center line of the 120 kilonewton load, and the resultant is also E over 2, and let's recompute for E for this situation. So E over 2, E over 2. So 19, let's call this R1 and R2. So 195 times E is equal to 75 times 9.15 this time. So this does not contribute. E therefore is 3.519 meters, and this time the distance of the 75 kilonewton load from the center line is 9.15 minus E over 2, and that would be 7.3905 meters, which is less than 7.5. Therefore, this configuration is correct, and the distance of the 120 kilonewton load from the left support is 7.5 minus E over 2, and that is 5.7405 meters, and the distance of the resultant from the right support is also the same by principle. So that is 7.15 minus E over 2, 5.7405 meters. The absolute maximum moment occurs under the heaviest load, so therefore it is just R1 times 5.7405 meters for this case, for this possibility here. So let's solve for R1, so taking whole system, summation moment about 2 equals 0. So R1 times 15 equals 195 times 5.7405. So R1 is equal to 74.626 kilonewtons. Then one possible moment, maximum moment, is R1 times 5.7405. So 74.626 times 5.7405. So Mmax is 428.4 kilonewtons meter. That's one possibility. The other possibility is only the heaviest load will lie on the span, and that the maximum moment or absolute maximum moment when there is only one load on the span would be when that is positioning at the center. And that is possible. Only the 120 kilonewton load will lie on the span, and it should lie on the center because that's big possibility when all loads move along the beam. So when that happens, the maximum moment would be PL over 4. So this is the situation. So remember that the next load, 75 kilonewton load, is 9.15 meters away, and that is greater than 7.5. So that's why both 75 and 20 kilonewton loads will be off span for this situation. So Mmax equals P 120 L 15 over 4, and therefore it is equal to 450 kilonewton meter. Since this is greater than 428.4, this is the maximum moment. Therefore, the absolute maximum moment is calculated by magnifying it. We add this contribution impact factor. Impact factor is equal to 15 over L plus 38. Should be less than equal to 0.3. So impact factor is 0.2830, and it is less than 0.3. So therefore, the absolute maximum moment is 450 times quantity 1 plus 0.2830. And that would be equal to, so the absolute maximum moment is equal to uh, 577.4 kilonewton meter. So that's it for the first question. For the second requirement, the absolute maximum shear force in the span, that will just be the reaction force at the left or at the right, depending on the movement of the loads. But since the heaviest load is, the resultant is closer to the heaviest load, when we computed E from this equation, because all loads rely on the span this time for absolute maximum shear, so we position the 120 kilonewton load over the left support as shown, and the resultant is 215 because the all loads rely on the span. 9.15 plus 4.27 is only 13.42, which is less than 15, the span. So the distance of 215 kilonewton load from the left is 4.44 meters. So the distance of the resultant 215 kilonewton load from the right is 15 minus 4.440, and that is 10.56 meters. So the resultant reaction here, which is R1 or Vmax, can be computed by summing up moments about the right side, and we only use the resultant because it's the same as the moment of the sum of the moments of its components, which are these three forces. So therefore, R1 times 15 equals 215 times 10.56. So R sub 1, which is equal to the maximum shear, is 151.36. This is also the absolute maximum shear. Therefore, since we have already calculated the impact factor, the absolute maximum shear is 151.36 times 1.283. So Vmax equals uh, 151.36 times 1.283. So the absolute maximum shear is equal to 194.2 kilonewtons. So that's it for this problem. I hope that you were able to follow and understand the solutions and the explanations. The principle of this is derived in structural analysis also in the mechanics of materials or strength of materials, that the maximum moment, absolute moment, occurs under the load, heaviest load, when that load and the resultant of the loads are positioned equidistant from the center line. However, does that not control here because the span is only 15 meters? You may try a span of 18 meters and 24 meters or greater than 20 meters so that all loads rely on the span, especially if it is greater than 20 meters, and try to compute for the absolute maximum moment or determine the absolute maximum moment, especially when L is 24 meters. If still the 120 kilonewton load at the center line will control. So that's it, and see you for the future sample problem videos in structural analysis.